Hello, it is 1:19 all day long. We are going to be talking about how to solve inequalities with the distributive property, but after we chat a little bit about your homework. So Izzy, let's talk about number 4. It is phrased in a kind of tricky manner. And this is on purpose because understanding inequalities is just as important as knowing how we solve them. So we start with this inequality, 5x minus 3 is less than 17. So what would be the first thing that you do here? Add the 3, right? So we add 3 on both sides, and that gives me 5x is less than 20. Then what would be the next thing that you do? Divide by 5 on both sides, and that gives me x is less than 4. A lot of people. Then mark the answer 4. Is 4 less than 4?
No.
No. So if I plug 4 in as an answer here, that's not true. What happens if instead of 4, I plug in 3? 3 is less than 4. 3 is your correct answer. Does that make sense how that's phrased really tricky? What is the largest positive integer that makes it true? 4 makes it false. 3 makes it true. Other questions from last night's homework? Quite frankly, love starting class like this. All you guys ever have to do is let me know that you have issues. Grr, let me tap you. There you go. What else? Getting my practice as Vanna White. She's the lady on Wheel of Fortune that taps the letters. You guys don't watch good TV.
I watch Wheel of Fortune.
Or it's
Jeopardy.
It's not Jeopardy. It's not Wheel of Fortune. Is it?
Family Feud.
Yeah, it's Wheel of Fortune.
Yeah, I watch
Yeah, Jeopardy's good. 9. You have a $50 gift certificate to a video store. Yes, there used to be stores like, Blockbuster or places that you would go buy videos back before Netflix.
Making me feel like a 44-year-old man.
So you just don't understand how quickly technology has progressed.
I know, but like some kids didn't know how to put in a cassette. I felt like so.
I have an 8-track player in my basement. So, and our record player is actively in use. Videos, like VHS tapes. You used to have to go to stores and rent them, or you'd buy them. And one thing about VHSs that most of you will never appreciate, they had to be rewound. You can't just skip chapters and things. So we're going to spend some money, right? I'm going to go buy a bunch of stuff. And I have $50 to spend. Can I spend all of it? Yeah. Most of you probably would want to. Could I spend more than that? No, that wouldn't make sense. So I could spend less than or equal to 50. How am I going to spend it? $7 each. Oh, this one actually has DVDs. There's another one with video cassettes in the problem. So, that 7, what do I do with it? Do you know, Lois, since you asked for this one? Do I only buy one DVD? Do I know how many I buy? No. So that's 7 times some unknown amount of DVDs. Has to be less than or equal to 50. This goes back to realistic problem solving. When I do the division by 7, sorry, I'm thinking of 49, I get the answer of 7.142857, and that keeps going. Realistically, how many DVDs could I buy? 7. So I know the problem, once we get to here, you know your answer, but on the mastery, you'll have problems like this that are posed. It won't give you multiple choice, and it'll ask you to solve it and give a realistic answer. So this is not what I'm looking for. What I'm looking for is we could buy at most 7 DVDs. Does that make sense? Other questions from the homework?
Which way would it be going the right way? The D.
What I can spend is less than or equal to 50. So, before we dive in to 9.4, I got back the survey results from the blended learning class thing that we did. And I want to say thank you because you guys had to fill out a survey, and that's time and effort. And surveys, some people like them, some people are just like, why are you asking me so many questions? But the short answer responses, or like the fill in, the write me a response, I mean, of course, it's all blind, so like I don't know who's who. But there was some really good feedback on there of like how I can get better, which, guys, I've only been at this for like, this is my 5th year. So I'm still a fairly new teacher. I can definitely get better. I know that I've got things to improve on. So one thing that I heard, I wouldn't necessarily say loud and clear, but a few different people said was that you would like more like activities, like get up, do things. So is this like, as we move through second semester, is that a general consensus that like if I said, okay guys, we're gonna go to the gym, or okay, we're gonna go outside, am I gonna be like, am I gonna get the response like, or is it gonna be like, yeah, okay, let's go? Because it's still gonna relate to math. It's still gonna be learning math. But we could like go do. So like if I, in this next chapter when we talk about angles, and this comes back to trust. If I gave you free time, like 15 to 20 minutes out of class, to go around the school, inside or outside, and take pictures on your cell phones of, so if, like, I would warn you, and then you guys could bring them to school, you'd be in groups, so you'd only need one device per group. And then you'd have to, like, share them or email them, like, examples of those mathematical concepts, like vertical angles and complementary angles and supplementary. Is that kind of general consensus that we kind of like more of that? Okay, so I still got to get through some more of those results, but thank you for doing that. I picked up your messages loud and clear, so I appreciate that. I have now that, you guys ever heard the expression kick in the pants? Like, if someone kicks you in the butt, it's like to get you going. So that was kind of my kick in the pants to totally do this. It's all blank paper. It's not all blank right now, but I'm completely like redesigning. Last year I did a complete redesign to let go of digits. So we went all Schoology. So now my redesign is going to be like, yeah, technology's great. Yeah, the blended piece is great. But how can we do like even more? So thank you for those messages. I will also be asking, and I don't know where I'm going to put it. It'll probably be the blue box over there right by Hayden, for you guys to just drop me Post-it notes of suggestions. So if you think of an idea of how something could be better, you don't have to put your name on it if you don't want. But I'll put a little, like a header page there that says like math suggestions or something like that. So if you think of something of how I could make math class better, whatever it is, an activity, something to do with the lesson, something to do with markers, I don't care what it is, give me suggestions. I need all the suggestions I can get. Cool? Thank you guys. So 9.4, one of the problems in math, no pun intended, one of the problems that we face is when we have choices. And this lesson, just like back when we did equations, is that sort of situation where we have choices of how we solve it. So as we go through this, we're going to look at the 2 different methods that we can use for this solution process. Please write down all of the steps. I know that's like, oh my gosh, it's so much writing. But when you go to do your homework, even if you're not writing down all your steps on your homework, you need something to reference back to. You should be using your notes while you're doing your homework. So what we see here is a reminder of the distributive property. So if you've got a highlighter, if I was you, I would highlight distributive property. And I would remind myself that we draw those arrows, because some of us are still struggling. Those arrows indicate multiplication. Because the multiplication happens twice. The A doesn't just multiply by the B, and that's where some people are stopping. They do A times B and then they leave C alone. That A has to multiply by every single piece inside the parentheses. So not just, If there was B plus C plus D plus E, I mean, you have to distribute to every piece in the parentheses. Over here, you can, to remind yourself, draw those arrows again. So in example 1, let's just do the distribution and solve this out just like we're used to. So we'll distribute the 3 to the P and the 3 to the 5.8. So I'm going to show out all my work. This becomes 3 times P plus 3 times 5.8. And actually, I'm going to put that in parentheses to show the multiplication. This is one of the reasons why we use parentheses. If I have 3.5.8 and 1 dot is multiplication and 1 dot is a decimal, I can get myself confused pretty easily. If I do this, I now see it's 3 times the quantity of 5.8. And it makes it a little bit easier. It's not right versus wrong. It's just notation differences. Is less than or equal to negative 28.2. So we should simplify that multiplication that we did. So if you want to do this in your head, what would be 3 times 8? Ignore the decimal for a second. 24, right? Bring the decimal back in. That's 2.4. 3 times 5? 15. So we get 17.4. This became a 3p and still less than or equal to the negative 28.2. Now, Casey, what is it that we are going to want to do first here?
Subtract.
Yeah, we always undo addition or subtraction if possible. So what do we subtract by?
17.4.
Because that's the number we're trying to get rid of. Oh, and another idea that's like halfway hatched in my head. Positives and negatives, I want you to start thinking about superheroes and supervillains. Or villains if you just call them villains, or bad guys, or whatever you call them. If I have a bad guy, negative 28, and another bad guy, when they combine forces, what's going to happen? They're going to make like a really strong bad guy. So when these combine with each other, they make a stronger bad guy, which is going to be a bigger negative number. So I just add the numbers together, and I make it negative. What'd you get, Hayden?
45.6.
So that's a negative 45.6. I've run out of room, so I got to move over here. So 3p is less than or equal to that negative 45.6. Sorry that I'm kind of writing at a slope. You want to finish us out? What do we do to finish?
You gotta take away the 3 to divide by.
We got to divide by the 3 because it was trying to multiply. And then
Why would it still be negative if you did?
negative 28 minus takes me further down.
Never mind.
So p becomes less than
Negative 15.
negative 15.2. And sorry, that's less than or equal to. Go ahead and try to graph that. I want to check if we remember what we were talking about yesterday. Go ahead and try to graph that. First thing you do, find your point, find your location, whatever you want to call it. Then decide whether it's open or closed. Then go whatever direction we need to go shading. So it's still up on the TV if you need it. Reagan, what'd you do first here then to graph it?
I found 15.2.
Found what number?
Negative 15.
Negative 15.2. So right between the negative 14 and the negative 16. And then
Isn't it closed because the or equal to?
this has or equal, which means this point is a solvable point. Then, Brandon, what direction did we shade? to the left because we're talking less than means down the number line. And then we just put an arrow to say it continues out that direction. Any questions on how we graph that? Okay. On your own, go ahead and try to solve the got it using that same method. Use the distributive property, distribute out, then undo any addition or subtraction that you need to, and then undo any multiplication division that you need to. Please stick up a hand if I can help you. Well, the 231's connected to the Q and the negative 35. So I still do that. We gotta distribute. We gotta do the arrows first. Because it's right up against parentheses and there's multiple things in the parentheses, we always draw those arrows. We can. Or we can multiply non-like terms. We can't add them. You can multiply anything you want. Because I can do like half of a set of monkeys. But I cannot add like trucks to monkeys. Like I can't add, like, but I can multiply things. Like I can multiply monkeys and trucks and make monkey trucks. But I can like so conceptually it's hard to discuss, but we can multiply anything we want. We can only add or subtract like terms. So yeah, a lot of us I see drew the arrows first to remind me that the division goes to both of those values. I'm going to go ahead, I see that on a lot of people's papers, I'm going to go ahead and put that up here. Ooh, that's not the number you want to get rid of. You want to get rid of values on the variable side. So that's the number we need to get rid of. Let's bring it back together because I feel like we're hitting that point where if we're having issues, we might be finding those issues. So Jack, when you distributed this, the 231 times Q, that one's not as hard to calculate, but the 231 times the negative 35, what'd you get there? It's a multiplication. Did you not do that? Okay, can you punch it real quick or something? Like, I mean, I just saw that you had a calculator on your desk, so. Abby, what'd you get?
I got 8,085.
And it's got to be negative since that 35 was negative. Are there questions on that step? Because I see a decent amount of erasing. Are we all good on why that happened now? So now, here's...
Good morning, Seth Anderson. Please come to the office. Seth Anderson to the office, please. Thank you.
Here's where your brain can kind of screw with you. Most of what we've been doing had the variable on the left-hand side, so we were trying to clear out numbers on the left-hand side. Where's my variable now? Well, is it left-hand side or right-hand side?
Well,
Of the inequality symbol. To the right. Because here's what I want to solve for. So, the first thing that I need to add or subtract to get rid of, Justin, what number do we want to get rid of?
8,085.
That's the one we get rid of first. I agree. We do also want to get rid of the 231, but not yet. So the first thing we do is add the 8,085 to both sides. Any questions on why we did that? We're trying to get the variable by itself. We always undo addition subtraction first. So now, I'm going to get 9,000.
8,141.
Yeah, sorry, I tried to carry that one way far over. 8,141.
Yeah.
Thank you. Is greater than, now we just have 231 times Q. So, Casey, to finish out here. Sorry, your car got shuffled back in. That's why you got called again like that quickly. Yep. So be careful how you say it. I bet you could write it right. But how we say this is we're dividing by 231. But you could say, I'm dividing 8,141 by 231. Your Q is still on the right side. We still have that same inequality. That division got me 30. Okay, so long decimal. So you said 35.2. So both the 2 and the 4 repeat, or just the 4? Both. Sweet. Thank you. So now we got to locate that. This inequality is going to screw some of you up. Because your variable's on the right-hand side. Joe, if you tried to read this variable, or sorry, this inequality, how would you read this? Like, so 35.
Wouldn't it be like 35 and 24?
Yeah, is.
Is greater than.
So what that's communicating is this 35 and 24 hundredths is bigger than my possible results. If I turn this around, I could make it Q is less than 35.24 repeating. If I flip the whole thing, now this is easier to think about what direction I shade because the arrow now tells me. Remember, if your variable's on the left, the arrow tells me what way to shade. I shade to the left. Any questions here? Excuse me. To just try to set up the situation. I don't want you to try to solve yet, but I want you to try to set up the situation described in this example. So you could set it up verbally first if you want, but I want you to try to set it up numerically. Highlight what's important. I'm going to highlight what I think is important. And then we'll come back together here in a minute. Yeah, it's a type of apple. So that's actually where, like, Macintosh computers, their nickname is just like Apple, and their short name is just Mac. Like, their company name originally was Macintosh.
Macintosh, Apple, computer.
So, not that it was necessarily the Apple, because I think they actually spelled it M-A-C-I-N-T, like whatever. But there is a type of apple called, like, Macintosh.
Wait, but why is the I capital?
Well, the computer company spells it.
Yeah.
Why
But I
is
bet
the
you they
I-
did that on purpose to not have the same spelling, but it sounds like.
Wait, why is the I capitalized if it's like?
Because I think that was named after a person whose last name was Macintosh. Like, he may have been the first person to grow that type of apple. Maybe Granny Smith was the first person to grow that type of apple. Hey, I got a chuckle. That's more than I get a lot of people. I'm going to give you another second. If you think you have it, your numerical inequality setup, check with somebody close to you. And here's a really important question. What is highlighted in blue? Does that care what type of bushels I have? It just cares how many. Ooh, so we want more than. That's be careful with that inequality. Is anybody confident and they want to go for a risk? Shane? Okay, so D is going to be our days. So I love it. I think you say that you put your D over here. I'm going to put it over here, actually, just because I like the numbers to come before the variable. It makes no difference. It's exactly the same. So then what'd you have? There is no or equal because we need specifically more than 100. A lot of farmers will not go to market until they have a certain amount of stuff to sell because it's got to be worth their time. One big thing about farmers, time is money. If I spend time away from the farm, there's work that needs done that still needs done. So time is really important to farmers. Why did you do 25 plus 18? So the fact that it set up the two different types of apples is a distractor. This is like what those standardized tests, it doesn't matter that those are Macintosh and those are Granny Smith. When it asks the question, it just says bushels. So then, Shane, I'm guessing you combined these, right? So what's 25 plus 18? 43. So that means every day he's actually netting 43 bushels. That's pretty good. So if we just reason through this mentally, would 2 days be enough? No. Would 3 days be enough? Yeah. If we want the specific answer, you guys should have seen me in math 2 yesterday. They apparently called me, they say, it was like a kid with too much ice cream or something like that. I forget what they said, but I got all excited because we were solving parabolas, and we got to the point where the calculator does all the work for us, which is nice when the calculator does the work for you, especially when you're working with a system with 3 unknown variables. We're working with systems of 1 unknown variable. So they're working with 3 variables that we don't know. Yeah, well, it's sweet because it's like really beautiful. So this actually comes out to be 2.32. So what that really tells me is really we'd wait 3 days at least. Because would 4 days still make this true? What about 5? 6? Yeah, so all the way up. So if we try to graph that, I know it's a song. If we try to graph this, we would start at that 2.32, but really, we're talking about 3 because this doesn't count, and we go that direction.
Because that's not a full number.
Yeah.
Or
Well, it's not a whole number. Be careful saying full, because I don't know what the definition of a full number is. Is it a number that like ate the other numbers? Like 7, 8, 9, is it now a full number? Bad math jokes. By the way, another good chance to plug the talent show. If you think you can tell some good jokes or bad jokes, as long as they're school appropriate, you could tell jokes for talent show. You can sing, you can perform. Talent show is coming in April. I need to plug this as much as possible.
chili and chocolate.
So now we see a situation using some mixed numbers. What's better than mixed numbers? Impropers. Try this on your own. But think, and actually on your own, meaning like you can work with partners if you want. Remember what we do to a fraction to destroy it, to cancel that out to 1. Can only be what? Can't be created or destroyed. Can be converted. It's also weird to think about the fact that like I can't create energy. So like when I push off the ground, that energy is going like into the earth. Yeah, like you can't like it can't just disappear. So like when I eat food, I'm gaining those calories. I use those calories to exert energy, but it has to go somewhere. So that's this really weird like. Well, it would like, but it goes into the earth. The earth absorbs it. Yeah. But like, it's easy to think about if you stand on a rolling chair and like try to like jump off it and it slides backwards. That's because it absorbed your energy. You have to have something to push back off.
Like the block.
So when we look at these mixed numbers and make them impropers, Abby, what is 3 2/5 as an improper?
That would be 17 fifths.
17/5 W plus 1 4/5. Julia, what's 1 4/5 as an improper?
Is that it?
9/5. All right, Abby, you complain because I didn't stay on you very long. What do I do next?
What you do next is, well, let's just 26.
Okay, this is just 26.
And then what you do.
I'm waiting.
Okay, so what you do next is it you. Oh my gosh.
I'm just moving where I'm writing because I'm gonna run out of space.
So do you subtract that, right? 'Cause- no, wait.
What do these two values both have?
Multiply by the reciprocal.
Not yet.
No, you combine like terms.
These are like terms. So we combine them. We get 26/5. W
Oh,
is less than or equal to
26.
26. Now, Abby, back to you, because you tried to say this a second ago. How do I destroy a fraction?
Multiply by the reciprocal.
Multiply by its reciprocal.
No, I got this.
Because any fraction times its reciprocal is 1. Because so the easiest way to think about reciprocals is think about fractions with 1 on top to start. How many eighths does it take to make, think of pizza. How many eighths does it take to make a whole pizza?
You really like pizza.
8. How many twelfths, if we have a dozen eggs, how many twelfths does it take to make a whole dozen?
12.
Because every time you're getting that other number, all you're doing is flipping that fraction. So how many fourths does it take to make a whole dollar? 4. Fourth. 4/1. It's just flipping. So when I do this multiplication, really, if you want to, and we've talked about this before, this multiplication equals this multiplication, and a number divided by itself is 1. So we get 1W is less than or equal to
5.
This is super easy. Number on top and number on bottom will cancel each other out,
Well, bam.
and we get 5. Yeah.
I did that just by taking 26/5 and turning it into a whole number.
Yeah, because it's in fifths, it will work. You can get a decimal number. But if it wasn't fifths, if it was something messy like sevenths, you wouldn't want to use decimals. So I agree. In this situation, that would work. Decimals would work here, but they won't always work out as easy as this process. All I'm trying to communicate to you is this is the easiest way to do it. And I know you guys like easy. Yeah. No, you've made a mistake somewhere. So check. Did you have 17 fifths, or did you convert everything to decimals first? Okay, so did you have 17 fifths? Did you have 9 fifths? When you added them, did you get 26 fifths? That's going to be your issue. If you can combine like terms, that has to happen before you start your solving process. So, Abby, actually, while you're talking and not listening, they tried what you tried to tell me first. When you tried to say, okay, multiply by the reciprocal, like if I come over here and multiply by 5/17, that won't work out to be the right answer because these can be combined first. So you gotta look for like terms. If we have like terms, we gotta combine them. Any other questions on this? Flip to the back. You are now the teacher. You know that Jimmy has an issue in his work. Now what you need to do is help Jimmy figure out where his issue comes in. So follow his process and look down through it. Just take like 30 seconds to a minute. Try to check every step he did. Did he do it right? I'll give you like 30 seconds and we'll start talking about this together. Hey, Abby, can you not try to like, yeah, thank you.
It's hard to see because it's all crossed out.
So yeah, look up here if you need to.
Only covering up with one.
Make these problems?
Hmm?
Make these?
They came from like kind of a
Digits?
textbook, not Digits. Digits was the software platform that they used. So like Pearson has a Math 7 textbook. This comes from that textbook. Next year, I believe we're actually getting a different text, and we might be getting a physical textbook.
Yeah.
Like not like you guys necessarily, because Mr. Hall had, but like Worthington as a district, because our contract with Pearson has expired. Like we don't have to stay with them.
Yay!
So Flynn, if you were solving this problem, you can kind of forget what they did for a second. What would be the first step that you would need to do? Or I guess I can flip that question to what's the first step he did? Ooh. So be careful with your verbiage. You had it right the first time. He multiplied the 16 with the z. But if we're really particular, this is a negative 16. So let's check if he did this multiplication right. The negative 16 multiplies by the z. Did he do that multiplication right? And then the negative 16 multiplies by the negative 3. What's a negative times a negative? Yeah, because remember, pairs of negatives cancel out to a positive. Is 16 times 3 48? That's what we got to, did he do his work right? Is 16 times 3 48? What's 3 times 6? 18, then 30 more. So that step checks out. He did all right there. Michaela, going from this step to this step, can you tell what he did? Like this 60 didn't used to be
What the
there.
heck? What is that?
How did he get that? So remember on that last problem that's still up on the TV, the vital thing was that we needed to combine like terms. Are there any like terms on this left-hand side that can be combined? Got it, or you want to pass it off? So, I'm going to help you out here. If I look at 12 and search for are there like terms, does 12 have a variable? No. So I need another number without a variable. This has a variable. It won't work. Does the 48 have a variable? No. So it can combine with my 12. That's how he made his 60. And we still have the minus 16. So that's still okay. So we still have a minute. Then the next thing he would have done, Grace, it's the next thing that he did apparently. What changed on the left-hand side? So now we're going from this step to this step. What disappeared? Anybody? The 60. So to do that, he would have had to minus 60 and minus 60. If I take 60 away from 21, Andrew?
It would turn it into a negative, but 39 is positive 39 instead of negative.
Should be negative. You are correct. With that, we will pick it back up there tomorrow. That should be negative. Please work on your homework and come to class with questions. I'm more than happy to start class fielding homework questions and help you guys out. You're back?
Yes.
You know, man.
Well, he wrestles. Wrestling's not